Okay, so we've established types of ions. We've talked about valence shell. We've talked about the general number of electrons found in the valence shell of neutral atoms. Now, there are two things that you will have read about: ionization energy. And ionization energy, as you recall, is the amount of energy needed to remove a single valence electron from an atom. So that is energy required to pull an electron off. In comparison to this, there is the competing concept of electron affinity. And electron affinity is essentially the energy released when an electron is placed into the orbital of an atom, essentially meaning when you add an electron to an atom. So you've got ionization energy, removing an electron affinity, adding an electron. You release energy when you put an electron into an orbital, and it requires energy to kick an electron out of an orbital. Normal. Now, if you've ever studied chemistry before, or as you've been reading and doing the homework, you realize that ions are positively charged. So cations, recall, positive charge, requiring, therefore, electron loss, which means they require energy to remove an electron. They go through an ionization energy process, essentially, you could say. In comparison to that, anions gain electrons. Therefore, anions are negatively charged. Okay, to keep this consistent, they are negatively charged. Therefore, that requires them to gain electrons. Okay, so why would one atom choose to gain an electron versus lose an electron? That has to do with essentially which process is easier to gain 8 valence electrons. Because think about it this way: if you have 1 or 2 electrons in your outermost shell and you remove those electrons, now your quote unquote new valence shell is guaranteed to be full. So removing 1 or 2 electrons is much faster than adding 6 electrons, or energetically more favorable than adding 6 more electrons. It takes a lot of, you have to find 6 electrons and find places to bring them from, okay? You have to pull those 6 electrons off of something. Versus if you've got 6 electrons in your existing valence shell, so you're in group 6, your oxygen, you only need 2 more electrons to have a full valence shell. There's much less energy required to pull 2 electrons from somewhere than would be required to remove the 6 electrons from that group 6 atom. So the key here is all about energetics, okay? And in general, we say if you are in group 3 or less, the general thing is you will be prone to lose electrons to become cations. That's the general rule. And of course, as you've probably learned in life, rules can be broken. Not made to be broken, but rules can be broken. If you are in group 5, or greater, then it is easier to gain electrons, gain 3, gain 2, gain 1. And because you do that, you become anion. So group 1, group 2, group 3, it's much easier, energetically more favorable to pull off 1, 2, or 3 electrons to put onto something else, therefore losing those electrons to become a cation, versus group 5, 6, or 7, where it would require the removal of 5, 6, or 7 electrons. It's much easier to pull from somewhere else 3, 2, or 1 electrons to become anions. So therefore, you see the general trend of group number versus charge of the ion formed is thus. Groups 1, 2, 3, we'll skip group 4, group 5, 6, and 7. And therefore, you'll see the following. Loss of an electron from group 1 means that the charge on that will be 1 plus. Group 2 loses 2. Group 2 therefore forms a 2 plus ion. Group 3 generally, for example, aluminum, 3 plus. 5, group 5 gains 3 electrons. Therefore, the charge will be 3 minus. This is to, because you remember, we're trying to gain electrons or to gain electrons to get 8, or lose electrons to get 8 beneath the current valence shell. So -3, -5, -3, not -5, sorry. Thinking about the group number 5, -3, -2, and -1 are the potential ion charges formed. We'll stop here for this lecture.